Question number 4. Three identical bulbs X, Y and Z, each of resistance 4 ohms. 4 ohms, 4 ohms, 4 ohms. Connected to a cell of EMF 12 volt, and the cell has negligible internal resistance. No internal resistance here. R equal to 0. Okay. The switch S is initially open. Calculate the total power dissipated in the circuit. Initially it is open. If it is open, what will happen to the external resistance, total resistance? Total resistance, see, here no current passes, so we are not going to consider this one here. We are going to consider only the resistance here, which will now be equal to 8 ohms here, because these two are in series, 8 ohms over here. So thus the total power dissipated, P is equal to V square divided by R, which will be 144 divided by 8. When do you get 144? 12 square by 8, so which will now be equal to 144 divided by 8 should be 18. So I should get the answer as 18 watt. 18 watt is the answer. Okay. Let us move on to the next one. The switch S is now closed. State without calculation why the current in the cell will increase. Okay. Switch S is closed. Now what is the condition? It appears like so. When it appears like this over here, now what will happen? See, this external resistance 4 ohms will come in parallel with these two. When it comes in parallel with these two, the total resistance here will decrease. How many marks is this? This for 1 mark over here. So he states without calculation. First, what you can say is you can state total resistance of the circuit will decrease. When it decreases, what happens? This implies the current will increase. Correct. Simple, because only 1 mark you need not do any calculation. You just need to show it. Okay. Next, deduce the power dissipated in Y with S open and power dissipated in Y with S closed. With S open and as well as S closed. Okay. The ratio of the power source. So when the S is open, what will happen? The voltage over here would be, see, this is 12 volt. So this across this would be 6 volt. And across this would be 6 volt. Okay, this is when this one is open, switch is open. When switch is open, what I will do is I'll write it separately. I'll write here. Okay. If S is open, Vy is equal to 6 volt. Vy is equal to 6 volt, then the power dissipated Py would be equal to 6 square divided by 4, right? So this is what is the power you get. I'm not going to calculate anything, I'm just writing this out here. Now, if S is closed, then what will happen? Let me go back to this. If S is closed, the total power drop here, voltage drop here is 12 volt. Here also it is 12 volt only. Of course, when this is closed, part of the current will go here. Okay. But the current multiplied by resistance, whatever you get over here, will remain the same, right? Because 12 volt is getting dropped over here. As a result of it, here once again you should get only 6 volt only. It should not differ, right? If it is not differing, then what do I get here? If S is closed, once again, Vy would be equal to 6 volt and Py would be equal to 6 square by 4. So what will happen now? The power dissipated in Y with S open and with S closed, both are same. So the ratio here is 1:1. Okay. Many of them will make a mistake by not reading this problem correctly, and what they do is they consider this power here is nothing but V square by R without, and with it will be V square by 2R by 3, which means what? They take the total resistance and calculate, and this you would have got an answer equal to P:1. I have seen this question many times. I have given this question in my question papers. I have seen many of them making a mistake. But see to it that first you read the question properly, carefully, and then answer this question. What is being asked? Is it across the full circuit or is it only across a particular component? That's very, very important to go through. Okay, next. I think we have come to an end to this. Let us look at the next problem by tomorrow. Thank you.